This is 2008 FRQ Form B, number 1, with calculator. And so let's read this. We're doing part C. So we want to do cross sections that are perpendicular to the y-axis. Here is the y-axis. Perpendicular will be this way. So the base, our slices of this building are horizontal. And so let me draw one of these. So here's one slice of the building. And what are you putting on top? You're putting squares. So let me draw a square on top of this. Ready? Whoa. So you kind of see that? It's kind of like standing up, hopefully, off the screen. It's hard to visualize this. And this is off a little bit. Let me do that. And they're squares. I don't know. It's hard to visualize it, but that's kind of what's going on there. And so your base is right there. Okay, so the question will be asked, like, how am I going to get points on the test? And part of FRQs is knowing how they're scored. And there's a difference how I'm going to score you and how AP scores you. I'm going to give you a lot more points than AP does. So the AP is actually a little harsher because you lose points. You lose a lot of percentage because each point is more than like 11% for each point that you miss. Because there's 9 points per. But if I give you more points, then each little point doesn't hurt as much and you learn the process better. So how am I gonna do this? So here we go. First of all, this is a calculator problem. So you do this on your calculator and I will show you. We need to find that intersection point and that intersection point. And so part of your points will be describing those. And so technically you would do this in part A. You wouldn't do this in part C. Once you do it in part A, you don't have to redo it for the rest of the sections. It's assumed that this is one problem and anything you do in part A carries on to part B and part C. So how would you do that? If you do this, for writing that, I would give you a point. Then, technically, you could do this on your calculator. I'm going to do this just by hand. You probably should do it by calculator to be safe. I'm going to square both sides. So I'm going to x squared over 9 equals x. How do you solve this thing? A lot of you at this point would divide by x. You should never do that because by doing that, you're assuming x is not 0. But what if it is 0? So that's a problem. I'm going to multiply both sides by 9. I'm going to subtract 9x from both sides. I'm going to factor out an x and then set each of these equal to 0. I get 0 and 9. Now, like I said, you can do that on your calculator. You don't have to do that by hand because this is a calculated problem. I would give you a point for finding those points there. Okay? And for my reference, I'm going to find the coordinates here. This will be 9, 3. How do I know that? Because the square root of 9 is 3, so I know it's 3. Now, again, all that could and should be done on the calculator. It's so easy to make a calculation error that you don't want to take that chance when you're allowed to use your calculator. So now that we have that, what are we going to do? We're going to take all these squares and add them up as I move from one end to the other, right? Oh, that's weird how it tilts. I don't understand why it does that. It's kind of cool. So how do I add up all those squares? What's the volume of my building? Now this you don't have to write the way I'm going to write it, but I'm going to add up all of them from 0 to 3, and I'm going to take the volume of each square sheet, okay? You don't have to write this. I do that so you understand the concept. I take the volume of each square. The first one all the way across, I add them all up. So that's what's going on here. That's the concept that we're doing. You don't have to write that. Why 0 to 3? If you see, we're stacking these up from the bottom all the way to the top. So where's your first one? Your first one is here where y is 0. And as you go across and stack them, the last one's here where y is 3. That's why you're going 0 to 3. If that confuses you, please come to tutoring, Argo Academics today, 105 to 2:30, and I will help you with that. But how do you find a volume of a sheet of cardboard? It's going to be the area of the shape times the thickness of the sheet, which is dy. And why is it dy? Because the thickness is that up and down. And you should know as you move up and down, what changes? Y changes. So that thickness is a change in y. But what shape do we have? We are told our shape is something, a square. Let me let this person in. We're told our shape is a square. What's the area of a square? An area of a square is one of the sides squared. So in this case, we would put b squared. Why b? Because I said the distance from here to here is b. So it's b squared. If I can figure out what b is, I'd be happy. So what is b? To calculate b, that's going to be big X minus small x. Because what changes as you move left to right? X changes. So you got to take your big X minus small x. Big X is this fuchsia line. So what is the fuchsia line? Big X is not x over 3. X over 3 is y. Y is x over 3. You want x. You need to solve for x. So on this, if I multiply both sides by 3, I get x is 3y. That's my big X, 3y. Minus small x. Well, on the number line, right's bigger, left's smaller. So my small x is this blue line. And what is x on the blue line? Y is radical x. I need to solve for x. I'm going to square both sides. So y squared is x. So now I know small x is y squared. See, x is y squared. So I'm going to put y squared. That is my little b, or little x. So now I found b is 3y minus y squared. So here is the money equation. It's going to be 3y minus y squared. Now, this is a calculator question, so you would just punch that into your calculator, which I will do. The answer, I'll actually show you on the calculator, but let me get the answer written down first. Let's see, this is 08, I believe. I hope. The answer is going to be 8.1. Let me do this on the calculator, okay? So 3y minus y squared from 0 to 3. 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 3y minus, no, that's not the right. 3y minus y squared from 0 to 3. 3y minus y squared from 0 to 3. 3y minus y squared from 0 to 3. Where is my mouse? There it is. So I'm going to put the function here. I'll show you. 3y minus y squared. You're going to say, you're using x's. You're not using y's. What's wrong with you? So the variable that you use doesn't matter. Z, P, Q, W. It naturally does X's, so just use X's. It doesn't matter the fact that on our paper we have Y's. The area is going to be the same no matter what variable we choose. So I choose X's. There is my base of my square. I put it at Y1 because it's a lot easier writing that way. So let me go to home screen and watch. Now I do math 9 to integrate. I'm going from 0 to 3. And what am I doing? I'm doing this, the length of a side squared. So I'm going to go alpha trace to get my Y1, and I'm going to square that. Look how clean and simple it is putting your calculator that way. And now enter, bam, 8.1 exactly. So that's why we get 8.1. The points breakdown. On the test, I'd probably give you a point for knowing 0 to, I'll do here, 0 to 3, integrating. I'd probably give you a point for knowing, oh, I didn't square that. I didn't square that. I would have got it wrong. I would have lost the point. It's squared. It's b squared. And I might even give you a point for knowing it's dy and not dx. I don't know yet, maybe. And 1 point for your answer. So that's the breakdown of this problem. 1 point for setting the functions equal to each other. 1 point for finding the intersection point on a calculator. You can let your calculator do that. 1 point for knowing to integrate from 0 to 3. 1 point for knowing the area of your shape. Probably 1 point for knowing it's dy and 1 point for the answer. So that's kind of a breakdown of how this would work on my test.